Hey students, it's Mr. Summers here. I'm going to be talking to you today about linear one-variable equations. So first things first, let's break out our notebooks and open up to a nice clean page, and we'll start taking some notes for tomorrow's flipped class activity. So we have here, let's discuss what we're going to do as far as this lesson and what our goals are. We're going to define an equation, we're going to talk about what a variable is, we're going to talk about what a constant is and what a solution to a linear equation looks like, and how to check the solution to see if it actually completes the equation. So let's get started, and we'll take some notes and copy these two definitions down. An equation is two sets of expressions that equal one another. Expression, just in case you're not sure, is a math phrase containing ordinary numbers. So an expression could be anything such as this. You could have an expression that is a plus 1, 3 plus 3, 6 plus x, whatever. And then if you set any of these equal to one another, then it makes an equation. Now you'd have to check to make sure the equation's actually accurate, but we'll get to that. So now let's start off with a linear equation. This is the basic form of a linear equation. So we have right here, it's going to be a x plus b equals c. Now we have the black letters are constants. They do not change. Blue letter, which in this example, blue letter is x, and it is a variable. Okay, so when we say variable, that means it can change, and that's our goal, is to figure out what x is. We're trying to find out the value of x. You look at the a and the b and the c and it might throw you off, but it really shouldn't. Right now it looks in rough shape, but we'll put it to practice, and if we just go through a couple together, I think we'll be okay. So let's look at 3x plus 3 equals 12. Now, here's our basic equation. As you can see, a is equal to 3, b is equal to 3, c is equal to 12. That's not too relevant, but you understand that those are the representative constants. They're not going to change until we get down to solving for x. So x is what we want to solve for. We want to make x by itself on the left side of this equation. We want it to be alone by itself, and that'll give us a nice solid answer. On the right side, we have to do the opposite of what we see on the left. So for instance, we have plus 3. We're going to subtract 3 to get rid of it, because like I said, we're trying to get x by itself. So we're going to subtract 3. Boom. 3's going off this side, off the left. It's done. So since we subtracted 3, we have to keep the equation nice and balanced. So the key here is to subtract 3 from the right side. Okay, so now we have 3x is equal to 12 minus 3 is 9. So now it's going to be the same deal is going to happen here. 3 times x. They're right next to one another, so that it indicates that it's being multiplied. So 3 times x, so opposite of multiplication is division. So 3 times, 3 times x, divide by 3. And then that's going to cancel one another out. So since we did it to the left side of the equation, we're going to do it to the right side of the equation. Got to keep it nice and balanced. So we are going to have x equals 9 divided by 3 is 3. Ah, great. What do you know? That's our answer. Awesome. So we solved for x. That was our goal, was to get x by itself and solve for it. Now we're going to check this. We're going to check our work and make sure that it's true. Because if x really isn't equal to 3, and the way we're going to check it is you plug 3 right in where the x is in this problem. Now they have to equal, so if 12 is equal on the right, we want this side to equal 12 as well. So to do that, we have to plug it in. So 3 times x, that's 3. 3 times 3 plus 3 equals 12. Okay, so 3 times 3, we're going to start there. Operation, PEMDAS, parentheses, exponents, the multiplication, division, addition, subtraction. So, first thing we see, we're going to multiply, because that's the first order there. 3 times 3, 9 plus 3 equals 12. Now let's see, 12 equals 12. Bada boom, bada bing. That is true. And now we know our equation is real. It means something. It's not just a false equation. And we have some validity to that. So what I want you guys to do is copy down these few problems, and I want you to go over them on your own. So we have 6x minus 5 equals 25. And we'll set the x, because that's our variable, and the variable is going to be blue. So we have, that's problem number 1, 5x times 3. To avoid confusion, I'm going to get rid of the x and just put a little dot. That's the same thing as multiplication. That little dot in the middle, it means multiply, equals 15. And now we have 4x divided by 5 equals 4. So what we're going to do for tomorrow in class, now that you guys have these jotted down, we're going to do a nice little activity that the winner of this activity is going to get 3 extra points on their quiz. And it's actually, everybody can win. It's not